Alrighty, we are going to be looking at linear programming. Now, linear programming can be used in things like marketing, as like a marketing tool for determining maximum or minimum values of maybe products. Whoops, my pen slipped. These values are called the constraints, and this is our equation. It can be used for finding a cost or productivity. All right, let's take a look at the red inequality. So 3x plus y less than or equal to 7. All right, let's solve this for y by subtracting 3x from each side. And we get y is less than or equal to negative 3x plus 7. So our slope is negative 3, our y-intercept is 7. Let me grab a line tool. Let's see, we have 1, 2, 3, 4, 5, 6, 7. Oh, just enough. All right. All right, so right here, we're going to go 7, and we move down 1, 2, 3 units over 1, down 1, 2, 3 units over 2, and we'll get us one more. Down 1, 2, 3 units over 3. So right there. Alrighty, now this is below the red line, so we're between the red line and the XY axis so far. Alright, so down there. Let's take a look at the blue inequality. We have, let me change that from a line tool to a drawing tool. X plus 2y less than or equal to 9. All right, well, if we're to find our, put it into slope-intercept form, we subtract our x. Now, this one's not going to look pretty. So we have 2y less than or equal to negative x plus 9. When we divide by 2, you notice everything's a fraction. We have y is less than or equal to negative 1/2 x plus 9/2. Well, it really isn't that bad. 9/2 is really 4.5. Okay, and since I have, let's get our, so 1, 2, 3, 4, and then halfway right here. Okay, let me grab my line tool. So 1, 2, 3, 4, halfway here, and my slope is negative 1/2, so that means it's down 1 unit over 2, down 1 unit, and over 2 units. And let's see, right there. I don't have to go any farther. Why? Because everything's below the blue line and below the red line. So right now we are on this area, this region here. And you notice our green line, x is greater than or equal to 0. Well, that's just the y-axis because it's a vertical line. So right there, we're bounded by the y-axis. And then the purple is the horizontal line, y is greater than or equal to 0. So it's just your x-axis. Okay, so what does this tell us? It tells me that I am this region here, because I'm above the purple, I'm to the right of the green, below both blue and red. So let's see, can we fill this? Yeah, there is my region. Now that we've got this graphed, what we're going to do is we are going to look at the equation. P equals 2x plus y. In order to use that, we need to find these corners, all of these places where these lines cross. So here, 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 and here. All right, so, well, the easiest vertex is this one right here, 0, 0. So 0, 0. And then this one here, it should be 0. Let's see. No, it's 2, 4. Well, if this looks like it we're plotted right, let's see. 3, 6. It's about a third of the way. So that's 7/3. See, 3/3, 6/3, 7/3. So 7/3 comma, and we're on the x-axis, so the value of y would be 0. And let's see, this next one, our x-coordinate here is 0, and we went up 1, 2, 3, 4.5, so 0, and it's okay if we want to use fractions or decimals, 0 and 4.5 or 4.5. Is it okay to use a combination of them? Yeah. This one I have decimals, this one I have a fraction. Why would I use a fraction for this one? Because thirds are repeating decimals. Halves are not. That's why. And then this last point here, we move 1 up 4, 1 comma 4. Awesome, we've got it right there. So 1 comma 4. Now, we take our equation, P equals 2x plus y. And we're going to test this for each of our pairs of numbers. Okay, so let's put our points. So we have the point 0, 0. We have the point, I'll just travel around the figure, 0, 4.5. We have the point 1, 4. And then we have the point 7/3, 0. What we're going to do is we're going to plug these values in for x and y. So we have 2 times 0, because x is 0, plus 0, because y is 0. So this value equals 0. And we can even say this is equal to p, so this gives us our productivity. All right, so 2 times 0 plus 4.5 is going to give us 4.5. And then 2 times 1 plus 4, well, 2 times 1 is 2. 2 plus 4 gives us 6. All right, so 2 times 7/3 plus 0. Well, 2 times 7 is 14. 14/3 Well, 3 goes into 12 4 times, and there's 2 left over. So this is really 4 2/3. Now, if we are asked to find a maximum value for our constraints, it is the value 6. Where is it found at? At 1, 4, when x is 1 and y is 4. If you were asked to find a minimum value, that means the smallest value, well, our smallest value is 0. So it's going to be 0. Where is it found at? At 0, 0. All right, and there's our linear programming. Have fun programming.